AI development has taken a huge step forward, shaking up the open source community. A new model trained on just 14% of the data used by its competitors is outperforming industry giants. Meanwhile, another AI is revolutionizing logical problem-solving with a method that involves hidden loops of reasoning. If you thought cutting-edge AI was only accessible to billion-dollar labs, think again. These new models prove that smart design can outperform brute force training. One of the most exciting breakthroughs comes from the open-source model OpenThinker-32b, created by the Open Thoughts team. This model has been making waves because it's fine-tuned from Alibaba's Qwen 2.53 toolbinstruct and boasts 32.8 billion parameters, along with a 16,000 token context window. What makes OpenThinker-32b stand out is its unique training approach. It was developed using the OpenThought's 114K dataset, which, as the name suggests, contains 114,000 carefully curated training examples. But this isn't just any random data. The dataset is meticulously structured, with each training example enriched with detailed metadata and ground truth annotations, ensuring higher reasoning accuracy and efficiency. The team took extra steps to ensure high-quality solutions by providing domain-specific guidance and test cases for coding problems. To verify code solutions, they even built a custom curator framework, making sure everything was accurate and reliable. For complex math-based problems, an AI-powered judge was used to check mathematical proofs, helping the model refine its reasoning skills and tackle challenging problems more effectively. Another impressive aspect of OpenThinker-32b's training process was its structured approach. The model was trained over 3 epochs, meaning it went through the dataset 3 times, using a specialized framework called the Llama Factory. They fine-tuned its learning speed with a Cosine learning rate scheduler and a learning rate of 1 × 10 to the power of -5, which basically means they carefully adjusted how fast the model learned to prevent instability or overfitting. When it comes to compute power, they used AWS SageMaker with 4 nodes, each equipped with 8 H100 GPUs. Despite the demanding setup, they managed to complete training in just 90 hours. Additionally, they worked with an unverified dataset, though details on how it was used remain unclear. The team ran 137,000 samples on Italy's Leonardo supercomputer, consuming 11,520 A100 GPU hours in just 30 hours. The results: even the unverified versions of the model performed decently, but the fully verified version still delivered the best overall performance. So, how does OpenThinker-32b compare to other open-source reasoning models? According to benchmarks, it's one of the strongest contenders. On the MATH 500 benchmark, which measures mathematical reasoning, it scored an impressive 90.6%. outperforming some major proprietary models. For general problem solving, it earned 61.6 on the GPQA Diamond benchmark, proving its versatility in tackling complex questions. In coding tasks, it showed solid performance with a 68.9 score on the LCBV2 benchmark, though it was slightly edged out by DeepSeek, which scored 71.2 in a similarly sized model. Overall, OpenThinker-32b is proving that open-source AI can compete with and even surpass some of the biggest names in the field. When it comes to coding tasks, OpenThinker-32b still has room to grow. But since it's open source, developers can fine-tune and improve it, meaning that score could climb quickly with community contributions. This open-source approach is a huge deal. Unlike OpenAI and Anthropic, which keep their data and training techniques locked away, OpenThinker-32b puts everything out in the open. Anyone can download the model, examine its code, explore the data, and even refine the entire training process. This level of transparency is a game changer, giving researchers, hobbyists, and smaller teams the opportunity to build upon its success. What makes this even more impressive? Efficiency. OpenThinker-32b is competing with, and sometimes outperforming, high-profile closed-source models while using just 14% of the data that some rivals needed. Take DeepSeek, for example. It trained on 800,000 examples, while OpenThinker-32b only used 114,000. That's a massive difference in data usage, proving that smarter training beats brute force scaling. Now, let's take a closer look at how OpenThinker-32b stacks up against DeepSeek R1, one of the leading models in this space. DeepSeek R1, developed by a Chinese team, is also open source, at least in terms of the final model. However, there's a key difference. They haven't released their training data, making it harder for others to fully understand or replicate their process. When it comes to performance, OpenThinker-32b slightly outperforms DeepSeek R1 in key reasoning benchmarks. Math 500. Benchmark, OpenThinker, 32, B scores 90.6%, edging out DeepSeek R1 at 89.4%. GPQA Diamond Benchmark, OpenThinker 32. B leads with 61.6 compared to DeepSeek's 57.6. However, DeepSeek R1 holds an edge in coding tasks and certain math-focused challenges like the AIME benchmarks, where OpenThinker 32B doesn't quite take the top spot. Overall, it's a tight competition, but what makes OpenThinker 32B so impressive is that it achieves similar or better performance while using far less training data. This is a huge win for the open source community, proving that efficient training strategies can rival models trained with significantly more resources. The OpenThinker team isn't stopping here. They've hinted at future upgrades, including expanding the context window and making architectural tweaks. And for those who don't have the hardware to run a 32 billion parameter model, there's even a smaller version available. For those who don't have high-end hardware, there's also a 7B parameter version of OpenThinker. While it's less powerful than the full-sized model, it's a great option for experimentation without needing expensive GPUs. But OpenThinker isn't the only exciting model in the AI reasoning space. Another powerhouse that's making waves is Huygen 3.5 billion barrels. Unlike OpenThinker, this model takes a different approach to AI reasoning, focusing on a unique technique called latent reasoning. Developed by an international team from institutions like the ELLIS Institute, Tübingen AI Center, Max Planck Institute for Intelligent Systems, University of Maryland, and Lawrence Livermore National Laboratory, Huygen 3.5 billion barrels is backed by serious research and aims to push the boundaries of AI problem solving. So, what makes Huygen 3.5 billion barrels special? Instead of relying on the traditional chain of thought method, where models explicitly spell out each reasoning step, it keeps most of its thinking behind the scenes. This means it refines its internal states repeatedly, without needing to generate and store every intermediate step in the output. The benefit? More efficient reasoning and the ability to tackle complex problems without cluttering the output with unnecessary steps. Huygen 3.5 billion barrels keeps refining its answer internally until it's confident enough to produce a final result. This approach is especially useful for handling complex or large queries without burning through a massive context window. At the core of Huygen 3.5 billion barrels design is something called recurrent depth, meaning the model loops through its hidden state multiple times during inference. Think of it like someone solving a math problem on the back of an envelope, going over their notes, making small corrections, and refining their answer without having to write out every single step explicitly. This method is particularly valuable for tasks that require extensive reasoning, like complex proofs or multi-step code generation. Instead of generating a long chain of intermediate reasoning steps, like traditional chain of thought (COT) methods, Huygen 3.5 billion liters iteratively improves its internal representation. By doing this, it drastically improves memory efficiency. Traditional COT models generate a lot of extra reasoning tokens, which can quickly become unwieldy, especially for tasks that already demand large amounts of context. Huygen 3.5 BBL avoids this by constantly refining its internal state, almost as if it's updating a mental notepad in real time. Instead of relying on more tokens or a larger context buffer to refine its reasoning, Huygen 3.5 billion takes a different approach. Under the hood, it's still a transformer model, but with a unique twist. It features a looped processing unit that allows it to perform multiple rounds of computation on its hidden states. Think of each iteration as an extra layer of logical processing, but instead of increasing the model's parameter size, these computations happen during inference. This means Huygen 3.5 BBL can dynamically adjust its reasoning depth, looping more times for complex problems while keeping things fast and efficient for simpler tasks. Training approach. Huygen 3.5 billion was trained on an enormous dataset containing 800 billion tokens, sourced from diverse domains including general text, code, and mathematical reasoning. This broad and high-quality training corpus ensures that the model is well-equipped to handle everything from coding challenges to academic Q&A tasks. What makes this even more interesting is how the training strategy aligns with its unique architecture. The model's recurrent depth allows it to refine its knowledge over multiple inference loops, making it both powerful and efficient efficient in tackling a wide range of reasoning-based tasks. The team behind Huygen 3.5 BBL designed it to go beyond simple memorization and single-shot reasoning, forcing the model to develop internal thought processes rather than just recalling stored answers. This approach ensures it can tackle multi-step logical and arithmetic challenges more effectively. Benchmark performance. Once trained, Huygen 3.5 billion barrels was tested on various reasoning-heavy datasets where it delivered impressive results. ARC benchmark, a dataset designed to challenge AI models with standardized test questions, assessing their logical reasoning abilities. GSM-8K, a popular math reasoning benchmark that tests whether a model can solve multi-step arithmetic problems without just memorizing solutions. Despite having a relatively small size of 3.5 billion parameters, Huygen 3.5 BBL outperformed larger models like Pythia 6.9b and Pythia 12b, proving that recurrent depth is a powerful alternative to just scaling up model size. Adaptive reasoning for efficiency. One of Huygen 3.5 BBL's biggest strengths is its ability to adjust its processing depth based on the difficulty of a task. For complex problems, the model can run multiple inference loops, giving itself extra time to refine its answers. For simpler tasks, like retrieving a fact or solving basic math, it can use fewer loops, speeding up processing and conserving computational resources. In practice, this means Huygen 3.5 BBL can be tailored to fit different hardware setups or time constraints, making it a flexible and efficient choice for a wide range of AI reasoning tasks. This flexibility is a huge advantage for real-world applications, allowing users to optimize performance based on their hardware and time constraints. Alright, that's a wrap. Thanks for watching, and I'll catch you in the next one.